Alright, on this second video for the 61 HV, we're going to actually soft enable. Keeping in mind that right now the board is ready to go, so that signal, the soft inhibit signal on J7 position 12, it's pulled down to ground, and when we open that closure, that signal is going to pull up. It's going to start charging up through resistor R13 and through capacitor C4, and we're going to take a look at that signal go high. We're going to take a look at test point 1. We're going to take a look at the effect and of the ramping signal, and then the output. And this is for the value of that resistor is R13, Tony?
374K.
374, just like the board that this customer Magnetek has. So let's go ahead and we're going to be looking again the output, and we're going to be, go ahead, Tony. There it is. Alright, so you can, so we notice that what happens here is the soft inhibit signal, which was pulled down to 0, gets pulled up to 12 volts instantly, and that's just that signal. However, the effect of the delay angle at TP1 can be seen because now the delay angle is charging through R13 capacitor C4, and this is starting to vary from this point inversely from the maximum value to approximately 12 volts down to the rail to about 0.15 volts. We notice that the actual output across the load started from 0, and it's not sometime later, in this particular case 500 milliseconds, that we start to see some output on the oscilloscope until we get to approximately, on this particular scale, 3.24 seconds when we have a full output. Let's do it one more time, Tony.
Okay.
And now we're going to take a look at the DC output.
You ready?
Alright, and then we have 470 volts, and we have 630 volts DC on the output. AC in the input, DC on the output, and again we get to see this here. So at this point, what we're going to do is we're going to inhibit. We are going to pull out resistor R13, and what we're going to do is we are going to change different values. It's actually not R13, it's R11. So I'm going to remove R11. That's my self-start resistor. And give me a few, Tony. We're going to have for illustration purposes, different values. So why don't we start with 100K, Tony? That's 10K. Do 100K. Alright, so let's just try it one more time. Again, our oscilloscope is set up for 500 milliseconds per division, so we can see that the time changed. We are not going to record it, so now we're going to go to 500K. Alright, let's go ahead and set it up, and of course we'll see that the time scale will, and it's probably not going to be seen on the entire scope, although we can see that the time has gone. Alright, this is the end of this second video.